All right, guys, I've a few questions on Twinset hose routing, how, what, where, and when, what the logic behind it is. So I thought I'll do a quick presentation on the subject. Hopefully that will spark some questions that we can address face to face in the shop or on a dive site or during a course, of course. So let's have a quick look on how to configure your twin regulators. This is specifically for manifolded Twinset with an isolator, not independent twins or side mount or anything else. Nothing inverted, just a standard, Hogarthian type, DR type Twinset. Okay. Right. So what are we going to be talking about? We are going to be talking about understanding the logic behind your setup. Why is what hose where? Okay, we're going to be run through the assembly step by step. Like I said, if you want to do this in person, come and see me in the shop or the dive site, preferably not when I'm teaching like 3 or 4 people at the same time. But yeah, we can talk about this face to face. It might make a bit more sense. And the justification throughout. Why is this hose on that brake and why is it routed that way? Okay. We could examine possible variations, although I'm going to keep it somewhat restricted to the type of configuration I am comfortable with diving and teaching. And we'll have a look at the optimum setup, in my opinion. Optimum in the sense of, how can we streamline and have the least amount of hose kinks in our setup. All right, let's have a look at the origin of the technology. I mean, where does this stuff come from? Did someone just make it up one day, or what happened here really? We really have to look at the process of these hose routings being covered by cave explorers. And now we see them at a local dive site. You see them at Delft, you see them at Cape and Ray, Wobster, Indak, wherever you go. There's a large degree of people that are running around with a fairly similar setup. Okay. Now, the reason that we go back to cave explorers or any type of serious overhead is because these are demanding conditions, right? Your equipment's got to be in the right shape, in the right configuration. It's got to be somewhat fault tolerant. So this is often where these things are developed and where they are, vetted in a way that if they go wrong, I hate to say it, but either you don't make your way back out, or you make your way back out and go, hey, I'm not doing it like that again. That was a bad idea. So these sort of more stressing scenarios and stressing environments kind of filter out what works and what doesn't work. So we might as well benefit from that and take that into account when we start learning to dive Twinset, rather than just cobble it together and it will do because I'm only at Cape and Ray, which is obviously not the way that we like to reason. All right. Like I said, method and techniques tested in extreme environments. We've already covered that. And we are training with the end in mind. And this is really important if you're doing anything with me. For me, it's like, I don't want to teach you something that then on the next course we're going to change or oppose or is no longer relevant. I'd rather give you a little bit more and show you something that's going to remain the same way and explain why we do it like that. Okay, even if it's a little bit harder or it requires a bit more time from a theory point of view. All right, so let's have a look at the basic anatomy of the Twinset. Well, we're going to have 3 valves, a left valve, a right valve, and a isolator. So when I say left, we talk about the left hand, left ear. When I say right, talk about the right ear, right valve, and the isolator in the middle. Okay, it's really important that you understand which ways these close and open. Okay, so the left valve closes by turning it backwards, and the right valve closes by turning it forwards. So they all close clockwards. Okay, but it depends on the angle of the valve. The isolator closes clockwise. I don't know how else to explain that. It is important to understand which way the valves open and close, because if you have any interaction with the environment, you're touching the valves by accident against the environment, it is possible that you are forcing them further open or forcing them closed. And that is actually part of the reasoning of why we put what we put in what positions. Okay, we're going to have two first stages, and that's pretty straightforward because we only have two 5/8 DIN openings. We're going to have two second stages. We do not need more than that. I have seen people with 3 second stages. There's no need for that. You have one primary and one secondary. We're going to have two inflators most of the time, one for the wing and one for the dry suit. Now, the dry suit can also be configured with an off-board bottle. I'm not going to go into that today, but that is certainly a way of diving that becomes more important when you want to not have the gas in your Twinset coming into your dry suit. For example, you've got quite a lot of helium. And we only need one SPG and one pressure gauge. We do not need two. We do not need senders. We don't need transmitters. We don't need any of that stuff. Keep it nice and simple, streamlined, and as little failures as possible, really. Okay. So interactions with the environment. What is there? Okay, accidental touching of the ceiling. Okay. Now, what would that do? On the right post, it would roll on a forward motion. Okay. Yeah, because we already said if we want to close that right one, we're going to turn it forwards. So if we're touching the ceiling, it will roll further on, wouldn't it? All right. That means that left post could close with sufficient touching. And if you've been diving long enough, you'll hear stories of someone saying, "Oh, I was diving down a big shot line, and the line could cut my valve," or anything like that. There are scenarios where people are unaware of the fact that their valves are touching something, and that they are, especially if they're serviced and smooth, and that they are slowly closing or quite abruptly closing. It's nothing to be scared of. It's just something to be aware of. Okay. And the purpose of this presentation is that we need to identify what direction they are going in so that we can determine what hose we want to place where. Okay, so just to quickly recap, the right posts, if we're diving in an overhead scenario, the right post would roll on and the left post would roll off, as in closed. All right. Donation of a regulator during an out of gas scenario. Again, we are referring back to an overhead scenario, whether that be a wreck, cave, or mine. Anything where you can't just go like, oh, let's just swim to the surface and do the classic CETA, which I wouldn't recommend anyway. But anything that means we have to exit in a single file. Okay, so whatever point the dive we're at, you come up to me out of gas, I give you my long hose because it gives us most distance, and it gives us most practical application in terms of trying to exit, and then you are the first one out, and I will be the second one out. Okay, so if I'm going to give you my regulator, and we are trying to get out of an enclosed space, it might not be the most clean exit. Do you think it would be more likely that there might be some touching of the ceiling? And do you think that with everything going on and the potential, maybe stress of trying to get out, it'd be harder to spot that and harder to notice that? And if so, if we just assume those to be the case, if so, would you rather be donating to someone in front of you that's potentially blocking the way out on a valve that could roll on, or a valve that could roll off? And the answer is, of course, on. Because the guy in front of you starts moving his fins like that because you don't know why. He can't tell you that you've just closed the valve. What are you doing? Okay. So that means that we have to put the long hose on the right post, because that means that if we are donating in a high stress environment, in an enclosed space, that we cannot, whilst moving forward, that we cannot end up cutting our casualties gas supply. That's really, really crucial and important. And that is the first part of determining where the hoses are going to go. All right. So the long hose is primary donate and will come from the right post, because it can only roll on in a forward propulsion, meaning that if you're out of gas, you're swimming in front of me, we're trying to get the hell out of Dodge, I can't close that valve by hitting the ceiling. Okay. Now, that then determines almost directly where everything else is going to go. The backup regulator, which is the one I'll be breathing off, will have to come from a different first stage, because you can't be in a scenario where you had a catastrophic leak and you're isolated with Twinset and you're closing one valve and you lose both regulators, because that would be idiotic. So if the long hose is going in the right post, the backup will be coming from the left post. All right, so we've assigned the primary post, which is the right post. That's great. Then we'll have to think about the primary buoyancy, which is our wing. And we have to think about a scenario where, for example, the wing is auto-inflating, the LPI is stuck open. Okay, so primary buoyancy, primary post. Now, there's two reasons for that. One, it makes sense because if we are donating gas, everything else is going wrong, we don't want to be losing our primary buoyancy. The second reason is that if our LPI gets stuck open because of dirt, because of grit, because of maybe lack of servicing, whatever, that's not a yes. It's, if it happens, it happens. It doesn't mean that you are a bad diver because you didn't get a service. That's a conversation to have on the surface. So if that gets stuck open, your dump valve is on the left side, which means that you're going to be dumping with your left hand, whether that's directly through the LPI above your head or on the kidney dump on the left. Either way, you're doing that with your left hand. Now, if you can't unplug that hose straight away, you're going to have to shut down the gas source, which will be, guess what, the right posts. So they need to be opposite hands, don't they? If I'm dumping here or kidney dumping there, I have to be able to close that post with my right hand. It has to be opposite. So primary buoyancy, primary post, and post opposite to the dump. All right, that's clear. Okay, soot inflation. Now, soot inflation will then automatically go to the secondary post or to an off-board source. That's either is fine. It doesn't really matter. Okay, so if we have a little look at the pictures at the bottom, you can see the sort of general cleanliness of hoses that we'd like to see. I'll show you some more pictures in a minute. The SPG, the one I forgot. Right, the SPG is going to go on the left and it's going to go away from the long hose, which sits on the right. Which is also part of the reason that most of our stages, or all of our stages, are going to go on the left. We keep that right hand free. We don't want a D-ring there. We don't want any clipping there. We just want our long hose to go around a retaining stick or around a umbilical torch canister. Nothing else goes on that side. Okay. SPG therefore goes on the left, nice and streamlined, etc., etc. And you don't need two SPGs. If you are in a scenario where you've had a catastrophic failure, you've isolated, either you're on the side of the SPG or you're not. It's not really that relevant because you're going up, you're ending the dive, and you're doing that fairly promptly at that point. All right, so pretty traditional sort of setup. Apex DS4s, run-of-the-mill regulators, arguably one of the most popular ones out there still. So what are you looking at here? So on the left-hand side on your screen where you're looking, that would be the right post. You see the long hose coming straight down behind the wing, and you see the grey hose sitting forward and attaching to the corrugated inflator hose. Great, really, really neat, love it. Okay, on the opposite side, you see that there's several hoses coming off. You've got a hose in the back that we can't see. That's going to be the backup regulator. You've got what looks like a MyFlex HD high pressure hose, and then obviously the opposite one will be sorry, not the opposite. The other hose there will be the dry suit, and it doesn't need to come across because there's no need. It doesn't have to cross over. As long as it's on the opposite side, that's absolutely fine there. Okay. Sometimes you see them like this. Okay. So the same regulators, but put on an angle, and people go, "Oh, why don't you do that? There's more strain on the hoses, etc., etc." There is more strain on the hoses, and the hoses are arguably less optimal on this one compared to that one. So why would people do that? Well, they do that because the sort of dipping that you create with the two regulators there creates a real nice space for the occipital ridges in the back of your head here, allowing your head to move back a little bit further, which means that you can look forward a bit better. It also means that you have a little bit more space to get to the isolator. So sort of slightly angled first stages is often done to create a bit of better field of view and a bit more space in an isolation. Okay. Why is a bigger field of view important? Well, if you don't have that, or the twin set sitting too high, what you're going to end up with is people coming out of train to see what's going on. And that's not really conducive to the type of training that they're trying to do, or qualifications that they're trying to achieve here. And then we talked about optimal. So this is what I consider optimal. I consider regulators with a fifth port to be the sort of holy grail for twin set diving. And it's quite clear because the fifth port here, so if you just run through the screen left to right, you see the long hose there on the turret, and you see the wing inflator coming through the fifth port there. Okay. And if we look at the right hand side of the screen, yeah, we see on the far right, we see the high pressure hose there coming down. Then one left to that, we see the dry suit hose there, and then on the fifth port, we see the backup regulator there. Okay. So these types of regulators, to me, give you the cleanest hose routing, which is why I personally prefer them. But each to their own, of course. Okay, quick summary. Long hose is going on the right because it can't roll off. The wing is also going on the right because A, it can't roll off, and B, it's opposite to the dump, which means that you can use both hands at the same time to resolve that scenario. The backup is going on the left post because it's opposite to the long hose, because we don't want two regulators on one first stage in case of catastrophic failure and need of a shutdown and an isolation. The dry suit on the left post, because it's the other regulator to the wing, so you don't lose both systems in case of a shutdown, or the dry suit on an off-board system. The SPG on the left post, only one is needed, and it stays out of the way of the long hose. So there we have it. That's basic twin set configuration and hose routing. I hope that has resolved more questions than it generated. And if not, by all means, give us a call and come and see us. Thank you.